I'm back, and you'll notice that I'm still wearing the same shirt that I was in the last segment, but now it's 1 week later, and it's now time to do parts 4 and 5 of your lab on electrical circuits, and we're going to be doing series circuits and then parallel circuits. So in our previous lab, we only used one resistor, and we used Ohm's law to be able to predict what would be the current in the circuit if we knew the voltage and the resistance, or we could use Ohm's law to predict the voltage if we know the current and the resistance. Well, we're still going to be using Ohm's law, but now we're going to expand it to multiple resistors. So you can have series circuits, you can have parallel circuits, and you can even have combinations of series and parallel circuits, but we're not going to do that. So we're going to restrict it just to 2 resistors, and we're going to have 2 resistors in series and then 2 resistors in parallel, and we're going to see how is it alike and then how is it different. And so now we need to go back to our FET simulation, and we need to get out another resistor. Now I've already done this for you, and so this resistor here you see is set for 18. So this one over here is going to be set for 12, and then remember that this one up here is set for 15, and then this one over here is set for 18. So this one here we're going to call R1. So this is going to be resistor 1, and then this second one is going to be resistor number 2. And what we need to do is put them in series. So if you can look this up on the internet and type in the words series circuit and then go to images, and it will show you what a series circuit looks like. Or you can go back to your notes here, and here is a picture of what a series circuit looks like. So you can see that it makes one gigantic circle. So a series circuit makes one circle. You can also think of it as being like a conga line. You all know what a conga line is, right? Dun 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 dun. Okay. So let's now notice there's no electricity flowing because it's not a completed circuit. So we need to complete the circuit. And now you have it. Now you should notice something. I'm going to let you do it, but take out resistor number 2 and then reconnect the circuit and look at the speed at which the blue dots are moving. Okay, then put the resistor back in and look at the speed of the blue dots. So the speed of the blue dots is related to the watt. So the flow of electricity is called the electrical, okay? And you can see that by increasing the resistance, it's doing something to the current. Okay, so that's kind of important. So take a look at that. All right, now we want to measure it. So we want to, oh, and one more thing is, do you see the bands on these resistors? And so the colors changed. So different resistances means different color bands on the resistors. Now if you want, go to the internet and you can do some research on it. And you can, so if you know the bands, you can predict what the resistance of the resistor is. Now we're not going to do that, but you should have just noticed that the colors changed on that. So we're going to measure the voltage, and we're going to measure the electrical current. Okay, so to measure voltage, we have to get out the voltmeter, and I'm going to let you do this. Well, all right. So let's measure the voltage on resistor number 1. Okay, then we can measure the voltage on resistor 2. Now you should know how to do this. So you put the probe here and you put the probe over here. Okay, now what about if you wanted to measure the total voltage? So we know what the voltage on resistor 1 is and the voltage on resistor 2. So how could we figure out the total voltage? Okay, so there we're going to take a probe and we're going to put it over here, and we're going to take a probe and we put it over here. So now we're measuring the total voltage across both of the resistors. And so I need for you to record that number. Another thing that you might find interesting is reverse the probes and see what happens. You should notice it's the same number, but the sign changed. So if you ever get a negative number, then that just means to reverse your probes. Okay, got that? Okay. So let's go back to the lab here, and we need to find the total resistance in series. Now, in order to do that, we're going to use this formula here. So when two resistors are in series, you just add the resistances. So you got resistor 1 and you got resistor 2, and you're going to add them together, and then whatever that number is, put that right here. That's going to be your total resistance. So now if we go down to this chart here, you can put right here what was the total resistance from using this formula up here. Okay, now you got your voltmeter and you measured the current, or you measured the voltage. So you got this one, and you got this one, and you got this one. So you're going to fill in that chart for your three voltages. Okay, so now let's go back to the simulation. And so now we're finished with the voltmeter. So we put that up. And now we need to measure the current. And so we get out our ammeter. And so you should know how you have to hook it up. You have to open the circuit. So we need to cut this thing open, and then we need to insert our ammeter, and I'll let you do it, so that it makes one complete circle. That's the way that you use a ammeter to measure current. But I also want you to get out another one. So if we get out another ammeter, I'd like for you to maybe open the circuit over here and stick this thing in there, or open it here, and you can get out as many of these things as you want. So you could put another one right here, and I want you to look at the readings on the various ammeters. So look at what the current values are. And so then you're going to put those numbers here. So the measured current that's going through resistor 1 and the measured current going through resistor 2. So put those numbers here. Okay. And now we're going to go down to here where it says to calculate the total voltage in the circuit, use the following formula. So voltage 1 plus voltage 2 is equal to the total voltage. And where is that voltage coming from? So if we go back to here, the voltage is coming out of the battery. So you'll notice that you have a voltage here and a voltage here, and then when you add those two numbers together, you get the voltage that's coming out of the battery. So that is always going to be true for series circuits. So you're going to have your voltages here, and then your two measured currents here, and then now you can put in this number down here. So all that's left is we need to calculate the currents. So we've measured the currents, but now we want to calculate it. Now this is where it gets kind of tricky. So if we go back to the notes, so go back to your lecture notes. And so here is going to be the procedure. So this column is how to solve a series circuit problem. This column is how to solve a parallel circuit. So which one are we doing? We're doing the series. So here's your procedure. Step 1 is to find the total resistance. Now we've already done that. So we did this part, and then we're going down here to part 2. Now, after I've explained this, remember that here is a worked out example of how to do this. So this is something that you can't learn in one day. You can't learn it in 2 days. So this is something that you have to practice over and over again until you learn how to do it. Okay, so here, so let's keep on going down here. You should have noticed that the current is the same everywhere in a series circuit. So now we're going to go back to here. And I said to take a ammeter and put it here, take an ammeter, put it here, take an ammeter and put it here. And you should notice that all 3 of the readouts are exactly the same. So they all have the same current. So everywhere in a series circuit, the current is going to be the same. Now if you want to know why, and I know that you do, you're saying, well, why is that true? Well, if you go down to here in the notes, I talk about how a battery is similar to a water wheel, and how an electrical circuit is kind of similar to water flowing over the water wheel and then causing something to happen. So you can read about this. And then down here, I talk about the formulas for total resistance in series and parallel. So you can read about that if you want to. And then here is series circuit written in terms of waterfalls, and here's a parallel circuit written in terms of a river that is going around an island. So if you want to look at that, you can, but it's not important. Okay, so what's important is that in a series circuit, the current is the same everywhere. So you need to kind of memorize that. All right. Okay, so now we're ready to calculate what the current should be. So we need to calculate the current. So we know what the total voltage is. So that's going to be the voltage on the battery. So that's the voltage on the battery, total voltage. We also know what the total resistance was. So you add the 2 resistors together, that's the total resistance. We also have Ohm's law. So let's write out Ohm's law. V equals IR. But I'm going to put a T for total voltage has to equal the total current times the total resistance. Now, I know this, so I can take these two numbers, put it in there, and then solve it for the letter I. And then that is going to be the current in the system, because the current is the same everywhere. So current 1 is going to be the same as current 2 is going to be this current that you're going to calculate. And if you're still confused about that, then remember, go back to here. And so here's a worked out example of how to do one of these problems. Now, once you got the current, you can figure out the voltage. You can get the voltages too, because we're going to write V equals IR, but this time instead of the letter T, we're going to put 1, 1, and then 1. So voltage number 1 has to equal current number 1 times resistor number 1. But you know current number 1 because you get that from up here. So you're going to take that current, plug it in there, plug in your resistance that you know, and then calculate what the voltage is going to be. So that's going to be your voltage number 1. And then how would you do voltage 2? So write down Ohm's law. V equals IR. But instead of a 1, we're going to put a 2. So we're going to have voltage 2 is current 2, resistor 2. And then we're going to take this current from up here, and then that goes there. We know what resistor 2 is, and then we can solve it for voltage number 2. So that's how you're going to do a series circuit. You need scratch paper. So in order to do this, make sure you have a nice piece of paper and a pencil sharpener so that you can be doing this. Don't do it in your head. If you do it in your head, you're bound to make a mistake on this. So let me put this away. All right, so now you should be able to fill in everything on this chart. So here's where you're going to put the current that you calculated. And then you're going to use this current that you calculated to figure out the calculated voltages, and you're going to put those over here. So by the time that you get finished with this, you'll have that entire chart filled in. All right, now we're going to take a break, and when we come back, we are going to do resistors in parallel.